All right, you guys, welcome back. We are going to be doing 10.4, which is areas of polygons. Okay, actually, let me change that. Area of regular polygon. It's important that we know that it's a regular polygon. Focus is killing me. This can only happen in a regular polygon. Well, let's write what the definition, which we all should know, of a regular polygon. A regular polygon, focus, is going to have all sides equal and all your angles. If they are not, then obviously this is not going to be the case. So again, only in a, doesn't like when my pen is directing that way, regular polygon. All right, so the first time, we can have two situations. I want you guys to be aware of both. If a circle is circumscribed about a polygon, what that means is the circle is outside of the polygon. So I'm going to draw that here. I'm going to draw a circle outside the polygon, first outside, and then let's draw a regular pentagon. And I'm just going to put a dot for the center. Okay, so that's our first picture. Now, we all know what a radius is. This is going to be a new word for us. But let's just write the radius because I'm not sure if you guys are aware. We also have a radius in a polygon. So the radius for, I'm just trying to move it so the focus. We all know in a circle, how can I write this? There we go. In a circle, we all know the radius is a segment from, we'll say, the center to your arc of circle. Great, we all knew that. Now, in a polygon, your radius, again, is from the segment, from the center to a vertex. And we all should know all radii are equal, which we know that. So, I realize how many times I say the word so, I get it. Polygon, vertex, circle, goes to the arc, and everything starts from the center. Great. Now you have this new one, which is called an apothem. Again, the wording is your apothem. I know it looks like apothem. I think I used to pronounce that in the beginning, but it's an apothem. So this is a brand new word. This is very important. We need to know this terminology. So let's write the definition. An apothem is a segment from the center of, now obviously you've never heard of it, so it's not in a circle. It comes from the center of a polygon and is perpendicular to a side. So key thing, it's perpendicular to the side and bisects that side. So an apothem is a perpendicular bisector of polygon, of a polygon. So let's highlight that. So there you go. Your apothem is the perpendicular bisector. Again, it's really important because you have a formula for any area of the regular polygon, and you need to know the apothem. Now, let me show it to you in a picture. So when you have a circle, again, it's circumscribed, or the polygon is inscribed. Circumscribed, again, means outside. Let's draw some things in. I'll stick with the purple. All right. So, oh God, there's that word so again. Here you guys have the radius of the polygon. How you know it's the radius of the polygon? Well, it is going from the center to a vertex. So this is the radius of the polygon, as well as we should also realize it's the radius of the circle. So in this case, because you're going to see it's going to vary, it's the radius of the circle. This is also the radius of your polygon. So that's the radius of the circle because it's touching it. Do not go down here, because really what we're focusing on, just so you guys are aware, and this is going to build, we're only really care about the polygon, hence its area of polygons. The circle actually just tells us some things and helps us along the way into deriving the things that I want you guys to come up with. So I don't ever want to go outside the polygon. Always stay within the polygon. So again, all of this is talking about regular polygons. I don't care about the circle right now. So since that note, I want to just worry about the polygon. So here you go. Center to the side. Perpendicular. Bisects it. Let's get a different color. This right here, this is your apothem. Okay, this marker is a little too thick. Your apothem, again, is the perpendicular, and it bisects the sides of the side of the triangle. The side of the polygon. There again is your radius. Let's see if there's anything else I want you guys to know. It's kind of it for right now. Actually, jot this one thing down. The radius of the polygon, just so you guys are aware it does, it actually bisects the polygon's vertex. So however many degrees are in that one angle, we can bisect it. All right, now let's just, again, so now you have the picture when I talk about the terminology. Now let's draw, a circle can also be inscribed. So that means the polygon is outside. So for this one, I'm going to draw a hexagon. Regular again. I think I'm drawing a hexagon, yes. And then I'm going to put the circle inside. That's fun, which means the circle is inscribed. Okay, hopefully that stops. There's your center. Oh my God. Hold on. Ugh, that was annoying. So if I ask you guys to draw the radius of the circle, you guys are going to draw it. I always want this triangle, so let me just highlight that. The most important thing is the triangle. So if I draw the triangle, I realize, again, this radius is the radius of the polygon, the radius of the circle, this is your apothem. If I draw the triangle here, because again, always have your polygon, so let's just maybe highlight that. And all I care about is the triangle. You're going to see how this is going to work. So this right here is your apothem. Again, your apothem is perpendicular and it bisects the side. If you look and you realize it's coming from the center and it's going down, touching the circle, in this, it is also the radius of the circle. So the apothem is also the radius of the circle when your circle's inscribed. Then this, that is going to be the radius, since it's going to a vertice of the polygon. And that's kind of all I want you guys to write for that. So now you kind of understand a teeny bit of the terminology. You see what I'm focusing on. I'm focusing on the polygon. I'm going to be working with the triangle. I'm getting ahead of us. So this is your apothem, your radius of the circle, and the radius of the polygon. When this one, you have your apothem, which is also the radius of the circle. This is the radius of the polygon. Now, what we're going to end up having to do is finding that central angle. Well, the central angle, again, is made up of two radii. So radii, radii. This is my central angle. Radii, radii. That is my central angle. So we all know to find the central angle, you take 360 and you divide it by n. And hopefully we realize n is the number of sides of your polygon. So in this case, we would be doing 1, 2, 3, 4, 5, 360 divided by 5. So the central angle is 72. Over here, 360 divided by 6, so your central angle is 60. But, I only want half the triangle. So once you get your central angle, you are always going to divide that number by 2. So in this case, this angle which we're going to work with is 36. In this case, when I take my central angle and I divide it by 2, I get 30. Again, I only want to work with one triangle. What you should notice is once I'm going to have to find this information, again, I'm giving you guys a lot of heads up. Once I have to find your apothem, the radius of the polygon or circle or the base in a pentagon, you're going to have to, I'll just star this. You're going to be using, here we go, different color, trig to work your way around. Again, you're going to use trig. Now, in this one, you guys would like me to do a hexagon because when we do a hexagon, if you look, you have a 30, 90. You all know this is 60. So if I give you a hexagon, what you're going to do to find me your other pieces of information, again, this is giving you guys a heads up, is you're going to work with your special right triangle. Because I'm going to ask you guys for exact when I do a hexagon or there's other shapes when you guys can do special right. And then I'll probably ask you guys to round when you're doing trig. So we can just put like a little side note, then divide by 2 because you only want to work with one part of the triangle because you have the other part. Okay, so make sure you have all of that down. Hopefully that makes it, I mean, it probably doesn't make sense for you right now, but an understanding. Now let's do a few examples so you can kind of get an idea of how we are doing the work. All right, question number 1. You guys know I'm going to underline things too. So first it says a hexagon is inscribed in the circle. So I like to draw the outside object first. So if the hexagon is in, think it's in the circle. Let's just go like this to kind of keep our notes neat. All right, so that means I have a circle. And let's draw the hexagon. Hexagon, hopefully we all realize there's 6 sides. There you go. I'm going to go like that. All right. Then I'm giving you guys a heads up. Always draw the triangle. I mean, if you want to continue this, that's fine. You're going to see me always work with just half of the triangle. And I'm going to pull that triangle out as well. Again, I stopped here. I do not want to go outside the circle because your apothem is of your polygon. So it says the radius is 7. So the radius of the circle. So here is the radius of the circle. This, in this case, is your apothem. And it wants us to find the perimeter of the polygon. Well, to find the perimeter of your hexagon, you need to know what are my sides. So what we're going to do is we're going to end up using your central angle and all those concepts to find the side. What I'm going to do is I'm going to take this triangle out so I can actually write on it and you guys can see. So I'm going to draw just the one little triangle, but I will continue and mirror the other one. And we should realize because this is what we're looking for. We want a side of the polygon. All right, so we know this is 70. So what you guys can understand, I'm going to stop saying so, is your first step is you're going to find, I'm writing CA, you guys should get that, which is your central angle. To find the central angle, 360 divided by the number of sides. The number of sides is 6. So we all know that this is 60. The whole thing is 60. You want to divide by 2. Done. Each angle, little guy, is 30, if you want to understand it like that. 30, 90, 60. So now you're working with your special right. You should know that because we're doing a hexagon. Okay, so 2, 1, rad 3. Crossing the 2 is the 7, so let's go to the 31st, which is 1, half of 7, 3.5, and then 1 to rad 3 times by a rad 3, 3.5 rad 3. I didn't really care about that, but it's okay. So that means, and again, the apothem, it also bisects the side. So if this is 3.5, this is 3.5, which means a side of the polygon is 7. There are 6 sides, so let's times it by 6. Perimeter, 42. Question is done. Again, these are just really basic questions for you guys to understand how I'm working with your apothem and finding your values. All right, let's do your next one. Should be pretty simple again. We have an equilateral triangle inscribed in this circle. So that means, again, the circle's on the outside, equilateral triangle. And all of them are equal. Radius is 10. So what I would do again is go to the center, draw the triangle that we're going to be working with. Now that you know what we're doing, just constantly be drawing that. The radius of the circle. So again, the radius of the circle is this, is 10. They want me to find your apothem. So in this case, we were finding this. In this case, we're finding the apothem. I'm going to take that triangle out. 10. Apothem created the 90. Now, one more time, let's find first step, central angle. 360 divided by 3 sides. So we have 120. And because, I'll just draw this here, that's your central angle. Again, we want to take that number and divide it by 2. Each angle is, well, not each. So the top angle up here is 60, 90, 30. Also, you could have realized, since this is equilateral, all of these angles are 60, and I told you the radius of the polygon bisects this angle. This whole angle is 60, so that means each one is 30. Now you're working with your 30, 60, 90 again. So we got our 1, we got our 2, we got our rad 3. Easy question. So my apothem is 5. From 2 to 1, 5. Now I'm going to add an extra part to this question. Apothem 5. If I asked you what is the perimeter, so I'm just going to put a star because it's adding the question. If this is 5, you know that this is 5 rad 3. Now, that's only part of it. So we have to times it by 2. So you should understand a side is 10 rad 3, right? Because this is also 5 rad 3. We all know that this creates the full triangle. So the side is 10 rad 3, and you have 3 sides, so your perimeter would be 30 rad 3. Just working our way around. All right, so those 2 problems were kind of just me showing you and explaining you how your apothem works, how the radius works, how you find the central angle. Here is your main part of the lesson. We're going to kind of take that all into finding the area formula for any regular polygon. Yes, any. So that means a square is a regular quadrilateral, an equilateral triangle. I still recommend you guys doing equilateral triangle formula. But here is your formula. Ready? Area of any regular polygon equals 1/2 apothem, and I'll write this in, times perimeter. That is your formula. Write it down, star it, highlight it. A stands for your apothem. This is why we needed to work with the problems, understand how to find apothem. P finds your perimeter. Again, the reason why I gave you guys those problems above. So formula, very, very important. Okay? Okay. Question 1. A side of a regular hexagon is 8. Find the area in radical form. All right, so all you have to do is draw the hexagon. You don't need to worry about the circle. I told you the circle kind of allowed us to realize how to find central angle and all this other stuff. But knowing that we're finding the area, again, please write your formula, 1/2 AP, especially since you just learned it. And then knowing what we're doing, I would recommend you guys constantly now draw this picture. 90 degrees. Okay, so a side is 8. So the whole side is 8, yikes, which means I only want half of it. Your apothem bisects the base, so that is 4. Okay, so I should have left some more room, but oh well. You know that side's 4. All right, here we go. First part again, central angle. You'll realize the numbers are repetitive. 360 over 6 is your 60. Divide that by 2. This angle is your 30. Okay, 1/2. Let's find the apothem. So we know 1, 2, 60's down there. Here is your rod 3. I want your apothem. I already have a side. Your side is 8. So if side is 8, this little guy is 4. We just want to get to the apothem. So 1 to rad 3, 4 rad 3. This was 4 apothem. Now just put it in here. Your apothem was 4 rad 3, which you just found. Perimeter. If a side is 8 and you have 6 sides, you should know your perimeter is 48. All you have to do is half one of these numbers, either half of 4, which is 2, 2 times 48, or half of 48, which is 24 times 4. Leave that radical, so 96 rad 3 is the area of your hexagon. Again, when you have hexagons, you're going to leave the exact, you're going to leave your radical. When you have your pentagon and your octagon, I can ask you, be aware of those. You're going to be doing nearest tenth, which means trig. Okay, let's go on. We have 5 of these and then 2 other problems. Or 3, actually. I added a new problem. Sorry. Okay, so we have a perimeter of the pentagon is 50. Find the area. So there you go. I told you guys about the pentagon. All right, let's write our formula. 1/2 apothem perimeter. What you might also want to do is jot in a number you actually know. We know, oops, sorry, the area to be 50. I lied. We know the perimeter is 50, so let's put our number here. Get rid of some things. So we want to find the apothem. So I'm going to do it again. I'm going to draw my pentagon. Probably should have drawn bigger. I'm going to take the triangle out. And as always, I'm going to do this. 90. I'm going to draw that triangle bigger so I can actually write on it. So if the perimeter is 50, what does that make each side? Well, obviously 5 sides, so each side is 10. If each side is 10, then that little segment here is 5. All right, now I need to find your central angle. So we do our 360 divided by 5. Again, you're going to know these numbers after a while. Is 72. Take the 72, divide it by 2. So you have 36. You want to put the 54 and work with the 54. It doesn't matter. It's all the same. This is what I want to find because that is your apothem. All I did was take this triangle out. Let's just highlight that. Give you guys a minute to continue to write. All right, so I told you you have to use trig now. You can't do your special rights. So we have opposite, adjacent, tangent. Tan 36 equals opposite over, opposite over adjacent. Was right the first time. Let's try that one more time. Opposite over adjacent. When you cross multiply, remember the x is in the denominator. I'll show this out because it's been a while. You'll do x if you cross multiply times 36 equals 5. To get x alone, we have to divide by tan 36. So in your calculator, do 5 divided by tan 36. Remember, do not round this number. I'm just going to write a couple digits up here. We get x to equal 6.88 0.19. That is your apothem. But the nice thing about you guys having that calculator, dot, dot, we'll just put dot, dot. The nice thing about you guys having the calculator is leave that in your calculator. Take that number, times it by 50. Take that number, times it by 1/2. Then to the nearest 10, now here's the catch. 10 square inches, not to the nearest tenth. 10 square inches. Well, if you put this in your calculator, I'm hoping you guys should get 172.0. That's what you would do if I said to the nearest tenth. If I said to the nearest 10 inches, you round that. So this answer is 170 inches squared if you want, but you know I told you it's okay. So that is the answer. Please double check that problem. Again, you have to do trig. I had my perimeter. You had to take the triangle out, work your way around. You're going to have to do trigonometry again. Cross multiply. You get your apothem. Just use your calculator, times it. And again, I just tried to throw in, make sure you guys are reading 10 square inches. So this is to the nearest tenth. When you round this, you can't round up because of that too. Okay? Let's try number 3. All right, so it says the length of the diameter of a circle is 20. Find the exact area of the hexagon inscribed in the circle. So if the hexagon is inscribed in a circle, it means the circle's on the outside. So I'm going to draw my circle on the outside, and then I'm going to draw my regular hexagon. You should realize, yay, for the hexagon, because you can use special right. You also know what we're doing since we're finding area, so right away, do that. Okay. The diameter of the circle is 20, so you know that this is the radius of the circle as well as the radius of the polygon. So we have 10, you have 90. Let's write our formula. Area equals 1/2 apothem perimeter. Leave a little room because I want to add an actual separate question to review yesterday's material. So we have 1/2. Do you know anything? No. So now we have to find our apothem and our perimeter. Okay, so I'm going to take that triangle out here. Oh, it's a terrible triangle, but whatever. 10. One more time, when you're finding this, you're going to do your 360 divided by 6, which is 60. Take it and divide by 2. 30 up here, 60 is here. Okay, we got our 2, we got our 1, we got our rad 3. 2 to 1, 5, 5 rad 3. I know my apothem is 5 rad 3, and I know that this is 5, so that means this is 5, so a side is 10. Okay, let's put our numbers in. Apothem, 5 rad 3. Perimeter is 10 times 6, so my perimeter is 60. Exact, do not round, you leave the radical. So again, do here, 1/2 of 60 is 30, 30 times 5 is 150 rad 3 is the area of your polygon. Now, just to review from yesterday, if I said, find the area of your shaded region. Now I'm going to shade this region. So let's say, here you go, here you go, here you go. And I should actually add this. I want the word exact. Remember, exact means no decimal. Well, that's an easy question. You're just going to take the area of the outside shape, which we talked about is the circle, minus now the area of your polygon. So that's why we wanted to learn how to do these types of questions. Oops, I forgot to color that. So the area of the circle, well, if the radius is 10, our area is 100 pi. Remember, area is pi r squared. Minus your polygon. There you go. Because I can just ask you that as your question. I could just say, find the area of the shaded region. You might have, from yesterday, not have known what to do, or you might have found the area of a segment and then times it by 1, 2, 3, 6. Well, this is another way you guys can do it. You can find the area of the circle and then minus your polygon.